Okay, so in the previous video, we looked at how to expand a single trig function, be it sine, cos, or tan, into its constituents using the double angle formula or the compound angle formula. In this video, we're going to be looking at doing the opposite. So when we have two trig functions in terms of sine and cos, we're going to look at how to combine it into a singular trig function. So this is the general rule that I've written out for you. So when we have some a sine theta plus or minus b cos theta, it can be any variation, where a and b are just some numbers, right? Then we can combine it into r sine theta plus or minus alpha, or r cos theta plus or minus alpha, where we are trying to find this r and we're trying to find the alpha value. Okay, so it says plus or minus, but it depends upon the question. So I'll explain to you why it's plus or minus later on. So let's go about just trying to solve a question. So if we say maybe we have 2 sine theta plus 3 cos theta. Okay, so our a and b are 2 and 3, and we want to combine them into one singular trig function. So this is where you need to be very, very aware or very familiar with your compound angle formulas, because in some cases they will say, oh, change it using r sine theta plus alpha or r cos theta plus alpha. So the question might tell you, and in other cases they might not actually tell you, so you need to decide yourself which one I'm going to change it into. So in this case, what I'm going to change it into is r sine theta plus alpha. Okay, the reason being is because of the way these two are written out. I can expand this using the compound angle formula, saying it's r sine theta cos alpha plus cos theta sine alpha. And as you can see, it's actually in a similar configuration because we have sine theta here plus cos theta here. We have sine theta here plus cos theta here. So they need to be matching. So they both need to be pluses, and the order of the sine and cos, whichever one is in front, has to be in the right direction or right position. So that's why I have to use r sine theta plus alpha. I couldn't use sine theta minus alpha, because then this would turn into minus, right, which is not going to be correct. That's why the compound angle formula, you need to be very, very familiar with it. Right, from here now, what I can do is equate what's what. So this 2 sine theta, I can equate to this theta term here, where sine theta is. So I can say 2 sine theta is equal to r sine theta cos alpha. Same thing with the r cos 3 cos theta, that's going to be equal to r cos theta sine alpha. Meaning now I can cancel out these here, and I'll be left with 2 is equal to r cos alpha, and 3 is equal to r sine alpha. Okay. So as I said before, our goal is to find this r and to find the alpha. That's what our goal is going to be. So to find the r, what we can do is, if I square this now, square each side. So 2 squared is r squared cos squared alpha, and 3 squared is r squared sine squared alpha. I'm going to write it here and just underneath it. Now if I sum them together, on the left hand side I'm going to get 2 squared plus 3 squared, and that's going to be equal to r squared cos squared alpha plus r squared sine squared alpha. Meaning 2 squared plus 3 squared is equal to r squared, take it, factorize it, in brackets cos squared plus sine squared, and as you can know, cos squared plus sine squared is 1, right? So 2 squared plus 3 squared is actually just going to be equal to r squared. So r is going to be root 13, like so. Okay, so that's how you find the r values. So in fact, when we're doing the questions, we don't actually have to show this part here. Okay, this is just a proof of how we get the r value. Right. Secondly, to get an alpha value, once again we look at these two initial ones here. So what we're going to do now is I'm going to divide. So I have r sine alpha divided by r cos alpha. These will cancel out and leave me with tan alpha, right? And that's equal to 3 over 2. And so therefore alpha we can work out as 56.3 degrees. Which means that I can rewrite this 2 sine theta plus 3 cos theta is equal to root 13 sine theta plus 56.3 degrees, like this. So this is how we combine two trig functions into a singular trig function. As I said, in the exam, you have to write every single thing out. So I'm going to just highlight what we need to show in the exam just to get the working out marks. So you need to initially show this part here, to show which one you are going to choose, or which one you chose and what's equated to what. And then we don't need to show this part here. It's just I'm just showing you how we do steps. We can move straight on to going to here. So an easy step is just saying these coefficients is going to be equal to something. So it could be r sine theta or r cos theta. It's just your job to know which one is what, basically. And then we can skip straight to here, where we can just say r squared is equal to the coefficients squared and add it up and find r. And we can skip straight to here to find our alpha value. So as I said in the exam, these blue boxes are all you need to be writing out just to get the full marks when you're trying to solve this question. And obviously we need to write out the final answer as well. Right, so as I said, important things to note are basically first of all, choosing which, unless they've told you to use r sine or r cos, choosing which one is the appropriate one depending upon the question, and then making sure you work out the r value and then the theta alpha value and making sure you write it in the correct form. Okay, so that's just the basic way of just finding out the r and alpha. And also another important a couple of like 1 mark, 2 mark questions which they could give you to trick you is asking you to find the maximum value. So they might ask you to find the maximum value of 2 sine theta plus 3 cos theta. Right, the way we do this is we just worked out previously that this is equal to root 13 sine theta plus 56.3. So essentially what they're asking us to find is to find the maximum value of this equation here. And the maximum value is actually just going to be equal to root 13, because if I was to sketch this graph, well, it's got 2 transformations, right? It's going to be 56.3 degrees in the x direction negative and multiplied by root 13 in the y direction. So it's going to look something like this, where here is root 13, here is negative root 13. So the maximum value is going to be root 13, and the minimum would therefore be negative root 13. This is just about visualizing what the maximum min is going to be. Now they might try and trick you with this max. So they might say, well, what's the max of, let's say, 10 plus 2 sine theta plus 3 cos theta. Let's say this is equal to h. So what's the max of h? Well, this is the same thing as h being equal to 10 plus root 13 sine theta plus 56.3. So the max h would be equal to just 10 plus root 13 like this. Okay, that's very like self-explanatory, right? Just add 10 to the maximum of these trig terms. But h might be quite a weird variable. So h might be, for example, let's say 10 over 2 sine theta plus 3 cos theta plus 10. Okay, so they're now asking us, what's the max of h? But h is a fraction, right? So for h to be as big as possible, we want the denominator to be as small as possible. So for in this case, what we're trying to find is actually the smallest value of 2 sine theta plus 3 cos theta, not the maximum, right? Because we want the max of h overall. And the smallest would be when it's equal to minus root 13. Okay, so the max h would be when it's 10 over minus root 13 plus 10. So just be careful with what the h or the variable or the equation is equal to. Another one, it might be like when h is, for example, something similar, 10 over 2 sine theta plus 3 cos theta squared plus 10. And then we'll ask once again, what's the maximum h? Max h means we want the denominator to be as small as possible, but the fact that we have a square means that anything we square inside is always going to be a positive value, right? So the smallest value this part here squared would be is when it's just 0 squared. So it's going to be 0 plus 10, so the maximum would be when it's 1, basically. Okay, so just be very careful of what the equation is and where the sign, where the terms are, and just find the max accordingly. Okay, so let's go back trying to solve a question. So it says express 3 cos theta plus 4 sine theta in the form r cos theta minus alpha. So they've told us what the form is likely for us. So we can say that 3 cos theta plus 4 sine theta is equal to r cos theta minus alpha. And using the compound angle formula, I can expand that. So it's cos theta cos alpha plus sine theta sine alpha. And I need to know what the number 3 is equal to, and that's going to be equal to the cos term here. So it's going to be the r cos alpha, because the cos thetas will cancel out. And 4 is going to be equal to this one here, so it's going to be r sine alpha. Remember, to find r, it's just r squared, it's just the square of each number. So 3 squared plus 4 squared, so r is 5. Simple as that. And tan alpha is something over something. Just be careful the order, right? It's sine over cos, so it's going to be 4 over 3 rather than 3 over 4. Therefore, alpha is going to be equal to 53.1. So this I can rewrite as 5 cos theta minus 53.1 degrees, like this. Okay, so that's all you need to write in the exam to get the full marks for this kind of question. Right, part B. Hence, find the maximum value of 3 cos theta plus 4 sin theta and the smallest possible value of theta for when the maximum occurs. Well, the max is very simple. It's just 5, right? That's very simple, right? But they're asking us when does it occur? Well, you can visualize it by sketching it. So if I try to sketch this graph here, this 53.1 is going to move to the right by 53.1, right? So the cos graph will be translated right by 53.1 degrees. This is 5. And so we're looking out for when is this theta here. So therefore, theta is just also going to be 53.1 degrees because it's just translated right by 53.1. So the smallest, the maximum value will be 5, and it will occur at when theta is 53.1 degrees. Okay, so let's carry on. So the temperature of Ft of a warehouse is modeled by Ft is 10 plus 3 cos 15t plus 4 sin 15t, where t is time between 0 and 24. Calculate the minimum temperature of the warehouse as given by the model. So f of t is equal to 10 plus 3 cos 15t plus 4 sin 15t. Luckily for us, even though it's 15t, the order is 3 sin plus 4, 3 cos plus 3 sin, which is the same as what we've been doing previously. So I can rewrite this as saying 10 plus 5 cos, rather than theta is now 15t, right? So 15t minus 53.1 degrees, like this. And then they're asking, what's the minimum temperature? So it's the minimum, so that's when this is smallest, right? So min will be when this is 10 minus 5, because the minimum will be negative 5, equal to 5. D, find the value for when this minimum temperature occurs. So it occurred when this term here was equal to negative 5, right? So I just need to find that t value for when it's equal to negative 5. And it's just a matter of solving for t. So this should be fairly simple. Because 15t minus 53.1 degrees is equal to minus 1. 15t minus 53.1 is equal to, this is going to be 180. So 15t is 233.1. T will be 233.1 divided by 15. So that's the time when the minimum occurs. So actually finding the R and alpha value is just a matter of just practice. And once you start practicing and get used to it, it's fairly simple. It's just the fact that they might ask you some weird questions of like maximum or when this maximum occurs. That's a bit more tricky. But once again, if you do practice it in your own times, then you should be fairly well prepared for this type of